Okay, so first of all, I'm copying all the asset names that I have in the historical data into a new table to calculate some basic parameters. So the first parameter that I'm gonna calculate is gonna be the average rendement. It's gonna be with the formula average, and I take all the information from the first asset, and then I'm gonna copy the same for the two other parameters, and I change the formula. Second one is gonna be with this best that m, and the third one is gonna be with the formula bar. When I have this, I just extend all this for all assets, and then I'm gonna calculate the portfolio V. This is with a random weight value that I put it for each asset in order to calculate a total V that is gonna be temporary. This portfolio V is gonna be the percentage that each asset is gonna take into the final portfolio. Now I'm gonna create a variance and covariance matrix in the data analysis option, in the option covariance. As input range, I'm gonna take all the historical data that I have. I'm gonna mark that I have titles in the first row, and the output range is gonna be this cell. Okay, so this is the table that Excel has created, and now I'm gonna put some format for this table, and now I'm gonna fill all the blanks with the information that I have in the left side that is corresponding with the right side. Okay, so once I have this table, I just select the range that I need, and I change the name of this range to matrix, as you can see in the upper left side. I do the same for the average rendement with perm, and for the portfolio V named as V. Okay, with all this done, I can estimate a temporary rendement and risk of the portfolio. So ERP is gonna be for the rendement, and BRP elevated to 0.5 is gonna be for the risk. So the rendement is gonna be with the formula sum product between V and the average, and the risk formula is gonna be a matrix operation between V and matrix, and a second operation with the transpose V elevated to 0.5. Then I put some format for these parameters, and I put the rendement as green and the risk as red. And now I'm gonna put the restrictions of this portfolio that are in the upper side, and I'm gonna add one restriction that is gonna be the width that needs to be 100%, and then a column for validation. So for the first restriction, I'm gonna add all the tests. Then for the second restriction, I'm gonna add the first, the second, and the third one bond. For the other restriction, I'm gonna add the test 5 and 7 years, and for the last one, I'm gonna put just the bond 5. Now I'm gonna create the interval table that is gonna have the risk and the rendement, and 5 intervals with the minimum variation and the maximum rendement. Also, I have all the assets for this portfolio, and then I add some format for this table. Once we have this, go to solver option, restart everything, and the objective of this is gonna be minimize the risk, changing the variables V that are in the upper side, and the first restriction is gonna be that the total V needs to be 100%. The second one is gonna be validation less or equal to 40%. The third one is gonna be a validation higher or equal to 25%. Third one is gonna be a validation less or equal to 30%. And the final is going to be a validation equal to the 5%. Then solve this, accept, and then we can copy as a value the risk and the rendement I have, and all the portfolio V in the first row, that is the mean variation. Then we do the same but maximizing the rendement. And again, copying as a value the risk and the rendement and the portfolio scenario for this scenario. And now for the interval, we take the risk below and subtract it for the risk above and divide it by 6 because we have 5 intervals, and then we add this interval for each risk. Now we can add a new restriction in solver. The reference is gonna be the risk in the upper side, and the restriction is gonna be the risk in the interval. And this is gonna be for calculate the rendement associated to this risk, and copy as a value the rendement and copy as a value the portfolio width that is associated to this risk and rendement. And we do the same for each interval to complete the 5 intervals. Having in account that it's important to always maximize the rendement in this solver run. Once we have this, now we can generate a dispersion chart with the values of the whole set of possible portfolios with a polynomial distribution, and adding the equation in this chart. And after that we can copy the values, the equation values, like number 1, number 2, and the number 3. After that we can create a table for estimations that is gonna have the a risk-free rate, deviation for that is the risk, and the rendement for this set. So the risk-free is gonna be the last data into the reference rate. The deviation is gonna be the number 3 minus the risk-free rate divided by number 1, and all that elevated to 0.5. And now I'm putting some format for this set, and the rendement is gonna be the number 1 multiplied by the risk elevated to 2 plus number 2 multiplied by the risk and plus the number 3. I put some format to these tables, and this is gonna be a special number, this rendement number, because we need to search it in the interval table, and this is gonna be the second and third one interval with this number is allocated, and this is in order to interpolate it and calculate its risk associated. So in an interpolation table we took the rendement and the risk, rendement as x and risk as y, and we took the data that we highlighted in the upper side for each rendement and risk. And finally we create a new table in the downside with the same information as the upper side table, but in the rendement space we're gonna take the 4.92%, that is the rendement, and the risk is gonna be with the formula that is gonna be y0 plus open parentheses, it's the x minus x0 close parentheses divided by x1 minus x0, and all of that multiplied by y1 minus y0, and that's gonna be the risk associated to that rendement. And in the solver we change the restriction to this risk to calculate the percentage of each asset of each bond to this scenario that is going to be the most optimal scenario for this portfolio.